we talked about arithmetic sequences. And we talked about sequences in general and all that fun stuff. Okay? Today we're going to talk about arithmetic series. You know, I kind of alluded to what that was yesterday, but we'll dive more into it today. And then Monday, we're going to talk applications. And we're going to take a formative on Monday. Okay? So, yeah, good stuff. I forgot to put the word problems on the homework packet before I printed it off. I know. Just another way that I have failed you as a teacher. No, because we'll have just done word problems that day. Yeah, so I'm not that. I feel as if there was something else I was going to tell you. Next week, Friday. Okay? Yeah, that's good. That was exactly what I was going to tell you. Yes. Yes. So the salmon worksheet is due next week, Friday. Now, you can do some of them on there right now, but some of them are geometric type problems. Okay? So just so you know. Okay? There is find the sums and all that fun stuff of geometric type problems. And that's not until that's Wednesday, Thursday, Friday of next week. Okay? Okay? So next week, it's actually a double formative week. It's a formative on Monday and a formative on Friday next week. But again, we will have a test before spring break, yes. A Friday before spring break, yeah, is when we'll have the test. Because that's only in 2 weeks. 2 weeks in today. Yeah, 2 and 1 now. 2 and 2 like yesterday. So yesterday we ended class on coming up with the rule, finding the rule given certain conditions. And the first condition that we had yesterday was we had the first few terms of a sequence. And then I asked you to find the rule and then find a specific term. Then the next style of problem was here is one specific term in a sequence and the common difference. Find me the rule and a different specific term. Okay? The third style of problem is given two random terms in the sequence. So what I'm saying here is, let me scroll up so that you can't see the steps so you don't see that. So what I'm saying is the 8th term of this sequence is 21. Yes. The 27th term of this sequence is 97. Yes. So those are two terms in the sequence. We want to find the rule. And I think, did we just find, I think this one's just straight up find the rule. Yep, this one's just straight up find the rule. Or we could do find the rule and then use the rule to find whatever term. Okay? So in this particular case, when you're given two rando terms, you've got to set up a system of equations. So we're going to use this. We're going to use our equation formula, or our rule formula that we got yesterday. We're going to use that twice. Okay? We're going to use it once on the first term that's given. We're going to use it a second time on the second term that we're given. Okay? So this tells me that 21 is my a sub nth term. I don't know what my first term is, a sub 1. I don't know what my common difference d is, but I do know that 21 is the 8th term, so n is 8. So that gives me the equation 21 equals a sub 1 plus 7d. match my energy. Yeah. Wake up. No, you're not. Then I got to go over to the other term, and I got to do the same thing. Now, though, 97 is going to equal the first term plus d times, that was the 27th term, was 27 minus 1. So I get 97 equals a sub 1 plus 26d. With me so far? Now, step 2 says, now I've got a system. I've got two equations with two things that I got to find. I got to find d, and I got to find my first term. So I can solve that system. Now, I'm not going to tell you how to solve the system. That's for you to decide. You've got four choices. You've got substitution, you've got graphing, you've got elimination, and you've got matrices. Your choice. But I will tell you that elimination is set up for you. Okay? Because I've got my red and my blue equations here, and they both have an a sub 1 in them. So I can take the blue equation, I'm just going blue just because it's the first one, and I can change all of the signs, multiply that entire equation by negative 1. And then I can take my green equation and when I add those two together, boom, goes the a sub 1. Gone. Eliminated. All I got to do is change the equation or change the sign in one of the equations. It doesn't matter which one. Okay? Negative 21 plus 97 is 76. Negative 7 plus 26 is 19. 76 divided by 19 is 4. So D is 4. My common difference is 4. Now, you want to go back into blue or do you want to go back into green? Blue. Blue, smaller numbers. Okay. So 21 is going to equal a sub 1 plus 7 times 4. So negative 7 is my first term. Step number 3 then says, now we can find the true rule for that, for this sequence. So a sub n would equal negative 7 plus 4 times n minus 1. And again, I would accept that. I prefer 4n minus 11, but will accept the upper one. Questions, comments, concerns, clarifications? Fantastic. Try that. And then find me the 25th term. So we've got 31 equals my first term plus my common difference times 4 minus 1, otherwise known as 31 equals my first term plus 3d. Then we've got 85 is equal to my first term plus my common difference times 10 minus 1, otherwise known 1 equals negative a sub 1 minus 3d. That gives me 54 equals 6d, which is 9 is my common difference. Agree with 9 being my common difference. If 9 is my common difference, then 31 is equal to my first term plus 3 times 9. 3 times 9 is 27. This is 31 equals a sub 1 plus 27. 4 is my first term. If that is the case, then my rule would be a sub n equals 4, being my first term, plus 9 times the quantity n minus 1, or a sub n is 9n minus 5, either one of those. Then we have, it was asked us to find the 25th term, which would be 9 times 25 minus 5. 9 times 25 is that 425? Yes, no, maybe? We all should have done it. 225? 225, yes, 225. Minus 5 then gives me 220. Agree? Good times. Good times. All right. Okay. Now, we're going to talk series for the remaining part of today. A series is just a sequence where you add up all the terms. That's the only difference. Okay? So a series is, so like the sequence for this one would have been 2, 4, 6, 8, dot, dot, dot. As a series, it's written like that. So you're just adding the terms together. Okay? But with that comes our old friend, or your old friend, sigma notation. Okay? So sigma notation starts with the Greek letter sigma, which is a really funky looking E. Okay. Then you have some kind of variable. You got 26 choices. Okay? Doesn't matter what you have. Classic mathematical type ones, they choose I. Why they choose I don't know. But it's either I or N, or it seems to be the two most popular ones. But you can choose anything there. And then this number down here is going to be your starting number. Why that's important is the first term is going to be you plugging the start number into the rule. The rule, you say, where's that? Well, that comes after the sigma. That's going to be the rule. Whatever's after that is the rule. So you're going to, whatever your variable is, that's going to be in your rule. The variable in your rule has to match the variable down here. Okay? So you're going to plug the start into the rule. That's going to give you your very first term. Then there's going to be a number on top, or there's going to be an infinity symbol on top. That's going to be your ending number. So your last term not end term. I want want to say last term here. You're going to plug your last term, or you're going to plug the end number into your rule to get the last term. Now, the other piece of data that you need from all of this is you need the total number of terms. And that's going to be n. And that's going to be your end minus your start plus 1. End minus start plus 1. Now, Sarah's sitting here thinking, why is Lynn's telling us all of these little parts? Guess what we need to find the sum? We need 3 things to find the sum of an arithmetic series. What do you think those 3 things are? First term, last term, total number of terms. Those 3 things. You're going to need to find those 3 things in order to find the sum of an arithmetic series. Okay? So the summation, or excuse me, the formula, I should put this, I will go back here, because I don't think it was on this, nope, it wasn't on this one. Okay? So the formula for the sum, so the sum is a big capital S, n is your total number of terms, so the sum is going to be n divided by 2 times the sum of the first term and the last term. That is the one formula for the sum of an arithmetic series. With me? But let's put it into action. Okay. Oops, first off, we're writing, I guess I didn't go very far. We can skip that slide when it comes up here. Okay. So, this one's just saying, write the series using summation notation. Okay? So, we start with a big old sigma. I need a letter. You've got 26 choices. N. Okay. N. I need a number between 0 and 2. Two's not between 0 and 2. 1. Good choice. Get it?
I thought, yeah.
Right. That's all that I have for right now. Right? Okay. So now let's look at this. 25 is my first term. Would you agree with that? Okay. 250 is my last term. I don't know how many terms there are, but do I know what the common difference is? What am I adding to get to the next term? 25. So 25 is my common difference. I can solve that one of 2 ways. The first way is I'm going to solve this side only, simplify that side. I get 25 plus 25n minus 25, which gives me just 25n, right? Agree with that? Okay. That, ladies and gentlemen, is the rule. So that would go here. The second way that I have to solve that equation is now I bring that 250 into play, which means that n here would be 10. That means that 250 is the 10th term, so that is my end number. And this then is the sigma notation for that series. We just said write the series using sigma notation. Now, if we wanted to find the actual sum, then we would take, now that we know that we've got 10 terms, so the sum of the first 10 terms would be 10 divided by 2 times 25 plus 250. 10 divided by 2 is 5. 25 plus 250 is 275. 1,375. 1775. 1375. So if we added up all of those terms, we would get 1,375. Okay? Now we should be able to skip some. Right? Series using sigma notation. I think we're good with that. We're going to skip that one. All right. So find the sum of this one. All right. Go for it. Find me the sum of that series. And let's do it this way too. And write it in summation notation. We'll kind of combine those things. We're changing it up as we go along. All right. So what do you want to do first? You want me to do sigma notation first, or do you want me to do sum notation first? Sigma first. Okay. So sigma is going to start with a big old sigma. Letter. N. Branching out. Gotcha. N equals 1. Okay. Like it? So then over here, I'm going to go equals A sub 1 plus D times N minus 1. And I'm going to say that 48 is equal to 3 plus, I got 5 as my D, times N minus 1. So if I solve the green, that would be 3 plus 5n minus 5. That would be 5n minus 2. Agree? Okay, that's my rule. Now I bring back in the blue. Add 2 to both sides. I get my total number of terms is 10. Agree with that for the sigma notation. Okay? Now then I can go to the sum. So the sum of the first 10 terms is going to be 10 divided by 2 times 3 plus 48. 10 divided by 2 is 5. 3 plus 48 is 51. 5 times 51. So the sum of the first 10 terms is 255. Agree? All around. Straight up, here's the sigma notation. You find me the sum. Well, what do we need for the sum? We need three things, right? We need the first term, the last one, and the total, right? Okay. How am I going to find the first one? How do I find the first term? Plug 1 into my rule, right? 3 times 1? 3. Plus 2? 5. Love it. Need my last term. And sub n. Plug in 65. 3 times 65 is 195. Plus 2 is 197. Total number of terms. How do I find the total number of terms? Nope. End minus start. End was 65 minus my start was 1 plus 1 gets me 65. So there are 65 terms. Now I can go to my sum formula. 2. Excuse me. $65 divided by 2 is literally 65 divided by 2. 5 plus 197 is 202. The nice thing is that, yes, 65 can't be divided by 2, but 202 can be divided by 2. So the sum of the first 65 terms is 6,565. Questions, comments, concerns, clarification? You get one of them is going to be an even number. So
But
you
it
can,
doesn't matter.
well, because this is, no, because this is 65 times 202 all over 2. So you only got to divide one of them. If you divide both of them, then you're dividing by 3. Just the meanest. Try this one. Firstest term going to be 12 times 6, that's 72, minus 8, that's going to be 64. Lastest term, that's going to be 12 times 80, what's that, 960? Minus 8 is 952. Total number of terms is going to be 80 minus 6, which is 74, plus 1 is 75. So the sum here of the first 75 going to be 75 divided by 2 times 64 plus 952. Ooh, I need a calculator on this one. 48. 1012? No. 1016. Right? $1,016. 508. 38,100. Yep. Okay. So on the salmon worksheet, right now, 1 through 5, 11, 12, 13, 14.